Okay, this is a part of chapter 1. So in this chapter, this is a revision of what you should have been learned during your high school or during your matriculation. Means that before entering the university, we assume that all of you have came across with this information. This is just general information. We call it the prerequisite information before we can move to the next chapter. Okay, first I will explain briefly on electronic device. So what is electronic device? Electronic device, this is electronic device that use and manipulates electric signal to complete a specific function. So a certain device should have a certain function or a certain operation. So this is why they made the device. For example, you want to have the amplifier. So the amplifier, the function is to make the signal bigger, or we call it to amplify the signal. So it should have a specific function. The device should have specific function and operation, and how they achieve the dedicated function or operation is by manipulating electric signal. So that's why we call it electronic device. So we manipulate electric signal or electron inside the device. Okay, this is the example, one of the example. Let's say we assume we want to have a very simple circuit or operation. This is the lamp. So this is lamp. This is the lamp. And then we want to turn on and turn off the lamp. Let's say when the room is darker, we will turn on the switch. Okay, we will close the switch and then we will connect the electrical connection and make the lamp turn on. So this is what we call it switching. So we switch the lamp on. Okay, actually the switch part, we can use a very common, let's say this one is push switch button. So this switch button, so this is switch button. So the operation of the switch button is we need to manually push the button. This is the input is manual, human finger, and then the operation, how the device connect the electrical connection is through the mechanical connection inside the switch. Okay. For detail, you can search how the mechanical switch work. So actually the mechanical switch, the operation is the main operation is something like what is shown in the symbol. Okay, what is shown in the symbol. So there will be a mechanical whether it's touch or not, whether the conductor is touched or not. So they will make the switching operation. But instead of having this mechanical switch, we can replace the switch with an electronic device. So example of electronic device which can operate as a switch is transistor. So this is transistor. So this is transistor. So this is what we want to learn, the device that we want to learn. So the input of the transistor is current. So what trigger the on and off of the transistor is input current. So the input is electrical signal, and the operation also involves the electric signal. So this is not about the mechanical operation, but this is involve electronic signal. So for example, in this circuit, we have the input is connected with the LDR sensor, so light sensor. So it can we can switch on this LED or lamp. This is LED. You can switch on the LED according to the level of brightness. This is the how the electronic device can be applied in the actual application. So what is electric signal? electric signal in the electronic device is actually from the electron movement inside the solid material. So I want to highlight the word of solid material. So because the electronic device is fabricated or is made from the solid material. So you know the material can be divided into solid phase, gas phase, and liquid phase. But now most of the electronic device is made from the solid material. So in the electronic device, the operation involve the control of amount of electron concentration inside the material or the manipulation of electron movement inside the material. Okay, since this is most of the electronic device is formed on solid, so next we can categorize the material based on their electrical conductivity. So we have conductor, and then we have semiconductor, and then we have insulator. So conductor is the material which can conduct better. So for example, metals. For example, metals such as gold, and then we have copper. So this is metal. So this is can conduct. This is very good conductor. And then we have the material that with a bad conductivity, or means that very low conductivity. For example, is glass, and then wood. So this is the insulator. So the insulator don't have the conductivity. So in between of metal and in between of conductor and insulator, we have material called semiconductor. So semiconductor is defined as the material which have what we call it. We have a middle level of electrical conductivity. Okay, so when we want to discuss about the semiconductor material, usually we will use this periodic table of the element. Okay, the common elemental semiconductor. Elemental means that the word elementals mean the material that consists of only one species. So for example, silicon. So in silicon, it only has silicon atom inside the material. So the common elemental semiconductors that will be covered in this subject is silicon and germanium. These are two common elemental semiconductors. Okay, so this is the silicon is very widely used in semiconductor material. So the silicon, and then the germanium. Although germanium is less used in general application, but actually germanium is the first material used for electronic device. Okay, so we see the silicon and germanium belong to group 14. So and then we see this silicon and germanium belong to the same group. Group 14 mean that it has 4 valence electron. So this is I will briefly explain it later. But anyway, silicon, germanium. So in what some of the information that can be derived or extracted from this table is this 14 atomic number. Silicon, the atomic number of the silicon is 14. So means that silicon has 14 electrons and 14 protons. The germanium has 32 atomic numbers, means that germanium has 32 electrons and 32 protons. Okay, so next I want to pose some question. Why some material conducts better? Why for example, semiconductor A has better conductivity compared to semiconductor B? So the main reason for that is it has more free electron, which is we call it conduction electron, because the electron that conduct the electric, we call it conduction electron. that can freely move inside the material. So in order for the material to be able to conduct electric, so it should have an electron that can freely move inside the material. So this is what we call conduction electron. So the next question is where the free electron come from. So actually the free electron come from the atomic structure of the material. Okay, so as you have learned, in atom structure, it consists of electron. This is electron, and then we have the neutron and proton that made up a nucleus. So we have proton and neutron. So you know, the electron, it has its own, we call it energy shell. Energy shell. So this is the first energy shell level, the second energy shell, and then the third energy shell. Okay. So the first energy shell is nearby the nucleus. So the bonding or the interaction between nucleus and the first energy shell is very strong. The second one is less weaker than the first one, and the third one here is more or less. Okay, this is example of, this is silicon atom. This is a silicon atom. Okay. Next, we will use one term. We call it valence electron. What is valence electron? Valence electron is electrons that are located at the outermost energy shell. So for this silicon atom structure, the example of this structure, the outermost energy shell, actually referring to this shell, the last one, the third shell. Okay, this is the third shell. So you see this is the valence electron. How many the valence electron there? 1, 2, 3, and 4. So we have 4 electron, 4 valence electron. So silicon atom has 4 valence electron. Okay, since the valence electron is located at the outermost energy shell, means that it is far from the nucleus, far from the positively charged nucleus. So it has less bonding with the nucleus. So when it has a less bonding with nucleus, means that it can be easily move, or easy to be released, or it will be involved in chemical interaction. So for example, if silicon, it have a nearby atom, so which electron will be involved, the interaction will be the valence electron. Okay, the first level and second level is quite stable. So the valence electron has higher possibility to become the free electron or conduction electron. So this is what the importance of valence electron in the context of electronic device. Okay, silicon has 4 valence electron. So in the previous slide, I show a individual atomic structure. But in actual material, it have many atoms inside the material. So the arrangement of the silicon atom is shown in this figure. So we have many silicon, and then in this figure it only show a valence electron. So if you see here, silicon, we have 4 valence electron. So 1, 2, 3, 4. So these 4 belong to this silicon, and then we have this another 4, 1, 2, 3, 4 belong to this silicon. So inter-silicon atoms, there will be a bonding. We call it a covalent bond. So this is the bonding which stick the atom together inside the material. So we call it covalent bonding. Covalent bonding actually means that the bonding, chemical bonding, that produced due to the sharing of valence electron. So this silicon and this silicon sharing electron. This is sharing electron. So this is what we call it covalent bonding. Okay, so valence electron involve the covalent bonding between the atoms. Again, I want to state here that in this course, this type of knowledge will not be covered in detail. So if you want to have a detailed explanation, you can refer to other references or other course. Okay, so let's recall back our previous question. Why some material conduct better? Why some material have higher conductivity? So it actually relate with the number of free electron or number of conduction electron. Okay, so this is the structure of the silicon material at the 0 Kelvin or without any external energy. So we can see here all the valence electron is at their location, or we call it at their energy shell. So but what happens when there is external energy? So external energy, for example, the heat energy from the temperature, can free the valence electron from the atom. So this is the figure show, the right side figure show how the electron is being released from the valence energy shell. So you can see here this electron is supposed to be here, but since it has external energy, so it is released. So it can release, and then this electron become conduction electron. So before it is valence electron, because of the external energy, it become the conduction electron. And now this conduction electron is not belong to any energy shell, so it can freely move inside the material. So when it's freely move inside the material, it can conduct electric. Okay, if you see these pictures, you can see that the release of one electron will produce we call it a vacancy. We produce a vacancy, we call it hole. So one electron will produce one hole. So this is what we call it electron hole pair. Okay, this is some question for you to think of. So how the ambient material temperature change the conductivity of a semiconductor? So we know that here, more external energy will produce more free electron. So it means that if the temperature of the ambient or the temperature of material itself is higher, so the semiconductor will have higher conductivity or will have a lower resistivity. So this is the question. Very simple. Okay, the next question is how much the needed energy to release the valence electron. Okay, because the electron inside the atom have their own energy shell. So each energy shell will have their own specific energy level or energy value. So the same with that, valence and conduction, or we call it conduction electron, have their specific energy level. And then energy level of conduction electron is higher than energy level of valence electron. If I draw the, let's say this is the axis of energy. So we draw the line, represent the energy level. So this is a valence, this is a conduction. So conduction level have higher energy level than valence. Okay, so we see here, in order to move from the valence energy level to conduction energy level, so this is the movement, there is a specific required energy. So this is what we call it energy band gap. This is what call it energy band gap. So energy band gap is very quite important parameter in electronic device. So material with low energy band gap will have more free electron. Why? Because it is easier for the valence electron to become free electron, because the required energy is lesser. Lower energy band gap means the required energy to release the electron is lesser. Okay, this is the statement. Silicon and germanium has energy gap of 1.12 and 0.67. So we can hear silicon has the band gap 1.12 electron volt. Electron volt is a unit for the energy. And germanium has 0.67 electron volt. Okay, from this value we see the germanium has lesser energy band gap. So we can expect the germanium to have more free electron because of less energy band gap. Because the electron inside the germanium it's more easier for them to move from being the valence to being at the valence energy shell into the conduction energy shell. Okay. Okay. So the external energy, for example heat, will produce a free electron and will produce a hole. What is hole? Hole is a vacancy left by the electron. So this is as label here. This is free electron and this is hole. Okay, the hole and electron. In electronic device, we call it a carrier. Carrier. Because of the carrier means that it carry the electronic or electric signal. The movement of the carrier will produce electric current. So for example, if we see the material has energy electric current to this direction. So current direction. So because the electron, let's say we assume that the current is due to the movement of free electron. Because of electron is negative, so the current is due to the movement of electron at this direction. Okay. But anyway, this is just a simple explanation. I don't want to explain detail, but the important point is you need to be able to recognize free electron and hole as a carrier. So this is the particle that contribute to the production of electric current. So free electron and hole, free electron and hole. These are the two carrier.